Hi, I'm Mr. Oh Ming Yeo. Okay, I'm going to discuss what is critical angle as well as total internal reflection. Okay, but before that, right, let's look at what happens when the angle of incidence is increased when the light ray is moving from air to water. Okay, from a less dense medium to a denser medium. This is what will happen if I have light ray 1. It's going to bend towards the normal. So 1 will go to 1. Okay, now light ray 2, if I increase the angle of incidence here, then it's going to bend towards the normal again. So if I have to increase the angle of incidence such that it is almost touching the air and water boundary, this is what will happen. The refracted ray is going to bend towards the normal. Okay, so when the light ray is moving from an optically less dense medium to an optically denser medium, right, basically it's just normal refraction that will happen. Okay, so now if the light ray is moving from water to air, okay, let's do the same thing again. I have light ray 1 entering into water, and when it emerges from air, it's going to bend away from normal. Okay, so 1 will go to 1. And if I increase the angle of incidence, 2 is going to go to 2. And if I increase the angle of incidence some more, 3 will go to 3. Okay, so now, as you can see, at this angle of incidence for 3, right, the refracted ray is almost touching the air and water boundary. So what if I increase the angle of incidence to 4? This is what will happen. The refracted ray is going to bend down further, and then it's going to touch the air and water boundary. Okay, so 4 is a very special angle, because at this very special angle of incidence, the refracted ray is moving along the air and water boundary, and it has an angle of refraction of 90 degrees. Okay, and for this 4, right, this angle of incidence, we call it the critical angle. And what if I increase the angle of incidence some more beyond the critical angle? The light ray is going to get reflected like a mirror. Okay, so this phenomenon at 5, right, we call it the total internal reflection. Okay, now let's do a recap. Okay, when the light ray is passing from a denser medium, we observe that as we increase the angle of incidence, the angle of refraction will increase slowly. Okay, and eventually the angle of refraction will become 90, and that is when the light ray will just go through the two medium separation. Okay, and this special angle of incidence, right, we call it the critical angle C. Okay, at this point, as we continue to increase the angle of incidence, the light will be reflected to the denser medium, and the refraction does not occur anymore, and this phenomenon we term it as a total internal reflection. Okay, okay, now let's do a summary. There's altogether 3 scenarios when the light ray is moving from an optically denser to a less dense medium. When the angle of incidence is smaller than the critical angle, normal refraction will occur. That means the light ray will emerge to the other medium and get refracted. Okay, when you slowly increase the angle of incidence such that it becomes the critical angle, the light ray is now going to go through the surface boundary. Okay, and you have an angle of refraction of 90 degrees. And if you were to increase the angle of incidence even further, right, this is what will happen. Total internal refraction will occur. Okay, so these are the 3 scenarios that are possible when a light ray is moving from an optically denser to a less dense medium.